All right, well, we have a few people joining us, Melody and Pietro and Eddie I see on the line. Thank you for joining us. This is an endeavor by GEI to kind of do a little bit more outreach in this COVID situation where we don't really get to go out and talk to people, but we wanted to share our experience in groundwater management, and we want to talk a little bit about some of the work that we've done under Sigma, and then probably, and then also some managed aquifer recharge work and data management systems, all kind of tied to the Sigma effort, but obviously those things are applicable, across a wide variety of areas, whether you had to do Sigma or not. But before we get started, just a quick round of introductions, if folks wouldn't mind. Most of the people from GEI can introduce themselves as they start their discussion, with a couple of exceptions. Kwabna, I don't know if you want to just introduce yourself quick. You're on mute though, and you're outside somewhere.
Yeah, hello. Yeah, my little daughter's running around screaming. So, hi, I'm Kwabna Santi, hydrologist and climate change specialist. GEI, I've been with GEI for the past 10 years, based in Sacramento.
Okay, thank you, Kwabna. About, I know Roger's in the car, so Mark, how about you?
Yeah, hi, this is Mark Ashenfelter, fisheries biologist by background, but I've been doing a lot of grant application work for I see there's some Inland Empire folks online through the WISSIP program, as well as the Willow Springs Water Bank program down just south of the Tehachapi's. So I've been getting a little more multidisciplined these days, we'll call it.
Great. Lydia, who is our organizer.
Yeah, good evening, everybody. Lydia Holland, I'm the marketing manager for the West region with GEI. Thank you for joining us.
And then the rest of Eric and Chris and Mike, they can take a minute and introduce themselves as they begin their discussion. So maybe with our guest, Melody, would you mind introducing yourself and who you work for?
Yeah, so can you hear me?
Yes. Yep.
Gotta make sure I unmute both buttons. I'm Melody Bailey. I work for Mojave Water Agency in Apple Valley, California. I'm a water resource supervisor. I oversee data collection with the field team and help out on a bunch of projects regarding aquifer recharge, data management systems, and some Sigma stuff. So.
Great. Hopefully we'll have some interesting things for you to hear. Thank you, Melody. Pietro?
Hi, my name is Pietro Cambiaso with the Inland Empire Utilities Agency. I'm the Deputy Manager Planning and Environmental Resources, and I'm involved in both the compliance side and also Will more also on the planning side as well.
Great. Thanks for joining us. And Eddie Lynn.
Hi, also from Inland Empire Utilities Agency. I'm an engineer in the planning department working in water resources under Pietro's team.
Great. Well, thanks for joining us, everybody. So I'm going to just go quickly begin this by just talking just a tiny bit about GEI. Certainly, there's a lot of information on our website, or you can contact any one of us that are here today if you want some additional information. But we'll just do a quick overview of GEI. And then I'll also talk about some of our experiences with Sigma developing sustainability plans. And then Chris and Eric will talk about some managed aquifer recharge experience that we have. And then after that, Mike will talk about data management system and also touch on a little bit on a communication portal that we've developed through the Sigma process. So next slide, Lydia. So this is our team. I'm Larry Rodriguez. I'm with GEI, obviously. I am based out of the Carlsbad office. We have offices throughout the West, and we'll show you a map here in a second. My background is primarily water resources planning. So I started in Sacramento, was there for years working, in consulting, and also worked with Kern County Water Agency, but in their Sacramento office. and then have slowly migrated to back to San Diego, where I grew up, but spent quite a bit of time in Bakersfield as well. And really in Bakersfield working with water districts on their water resources planning, and then lately a lot of Sigma efforts there too. Next slide. And so with GEI, those of you who aren't familiar with GEI, we're a national company. Our focus is geotechnical, environmental, water resources, civil design, and construction management, a lot of different areas that we cover. And it does vary a little bit across the United States. On the West Coast, we're really probably our strongest water division is here. And that really goes back to an acquisition or a merger between GEI and Bookman Edmiston Engineering, Bookman Edmiston was responsible for doing a lot of design of large infrastructure projects for irrigation districts in the Central Valley. Both Mike and I worked at Bookman Edmiston back in the 90s for quite a bit of time, and then we found our way back here. But we cover a lot of different kinds of services. I think with the services you see here, we touch on all of those in California. Geotechnical, we do a lot of dam work. We were heavily involved in the Oroville project, and the projects that were spurned by that for reevaluation of spillways, we were pretty heavily involved in a lot of that work too. Environmental, we do a lot of CEQA NEPA regulatory work. And then in other parts of the United States, we do a lot of remediation work. And so we have a pretty large staff that does that. And then civil design and construction management. So pipelines, other infrastructure related to water, and then construction management services as well. Next slide. And so, as I said, we're nationwide. We have 4 offices in California. Our largest office is in Sacramento, probably 120 people or so. These days, not so many. Everybody's working at home, as you guys are all aware. We also have an office in Oakland, an office in Bakersfield, an office in Pasadena, and an office in Carlsbad. And so, and then I think roughly about 40 offices throughout the United States. Next slide. And then what we've done, our experience in California, particularly related to groundwater resources, this just shows you a map of the different types of work, groundwater related work that we've done in the state. And so whether it's groundwater management and planning that we've done a lot in the Central Valley and along the coastal areas, and even down into Southern California as well. The groundwater management, other groundwater studies like recharge projects and things like that. We've done quite a bit of that, some modeling, and then also some managed aquifer recharge. So it just kind of gives you an idea of where our staff has experience and the different areas and concentrations. As you can see, there's quite a bit of concentration area at Bakersfield. A lot of work there, and also Northern California too. So our groundwater experience is pretty varied geographically and also by service sector. Next. And again, just a little bit on our Sigma experience, where the kinds of work that we've done and the entities that we work with, and hopefully that's big enough that you can read that, but where we've completed GSPs, where we're currently working on GSPs, a lot of the annual reporting that has to be done. We just completed GSPs in January of this year, and we already have had to do annual reporting in April, actually twice this year. So the requirements, to get moving on various aspects of Sigma are pretty significant. We also help our clients quite a bit in acquiring grants. And so we've done quite a bit of grant applications for the various districts and entity GSAs that we're working for. So we've been pretty successful in trying to secure grant monies to help them do these studies. And then data management systems and the groundwater communication portal, just a couple of key items there. And again, you'll hear from Mike about those several items. Next. So I just want to talk a little bit about, the fact that we've completed a lot of the GSPs in the critical basins. And so, what's next for us? And I know that in the districts that most of you are working in, you don't have to do GSPs. It's not something most of you are active in. So, but you know, it's interesting to see kind of where we go from this new planning document, and you know, our timelines for getting something done. We have to be sustainable within 20 years. And so, next slide. And so, you know, I'm gonna go through kind of what next, and then some of the projects and management actions, and the different items that those entail. Those are really the nuts and bolts of sustainability. And so we'll kind of go through that, and again, pretty quickly, just to see the kinds of things that some of these districts that we've been working for are proposing, and the things that they're going to have to implement here over the next 20 years. Next. Okay, so what next? Go ahead, Lydia. Thanks. So, you know, we've submitted the plans in January. DWR has 2 years to review, and in that review, they're either going to approve the plan, they're going to deem it to be incomplete, or they'll deem it to be inadequate. Ideally, all our plans are approved, and we just continue moving towards implementation. Probably a lot of plans will have some level of deficiency that the department will identify, and they'll be called incomplete. But then we have a certain time period, typically about, or at least what the regs say, about 180 days to make up for any deficiencies. And I expect that a lot of plans, you know, will be facing that. And then you could have a plan that's completely inadequate, and you know, the level of deficiencies are so great that they're going to deem it inadequate. Obviously, there's going to be opportunity to review the plans, but in that case, you may also have to deal with potentially the Department of Water Resources and State Board coming in to have some hand in how you manage your basin. So you know, we certainly don't want to be in that category. We only have 20 years to reach sustainability, and I say only 20 years because when you look at the kinds of projects that we're trying to implement in some of these areas, you know, infrastructure projects take time, and the planning that it takes to get these things done, and then, you know, permitting and environmental documentation, construction, all that funding takes a lot of time. So the 20-year horizon is actually going to be pretty tight. And in that time, we not only need to implement projects and management actions to reach sustainability, but we also have to look at some of the things that we weren't able to complete and to get a better understanding in developing our plans. And so I'll touch a little bit on that in a few slides here. Next, Lydia. And so projects and management actions. So we really identified I kind of broke these out into kind of policy issues, and then also projects and management actions. And so from the policy perspective, we're really looking at implementing policies that change behavior. And so, you know, we're looking at developing pricing incentive to reduce groundwater use, or to set groundwater allocations. And I know in a lot of areas, particularly where there's already adjudication, you know, this is old hat. But for some of these, you know, irrigation districts in the Central Valley, this is something relatively, well, it is new. It will not happen easily, and that's one of our big challenges. So, for example, I'm working with a couple of districts to set, you know, some tiered pricing structures and figure out where we need to do that in order to incentivize people to use less groundwater, but also to generate some revenue to help find additional supplies to offset some of the reductions that they would have to see from pumping. You know, looking at, you know, other water development projects. And then also we've worked with districts to set fees on trying to discourage any new development of groundwater demand. So in an agricultural area, if you don't already have a demand on an acreage, you don't want to be in a situation where somebody's allowed to come in and plant a whole bunch of new trees, because that's something that's going to be very difficult to manage and maintain your goals for sustainability. Next slide. And then project refinement and implementation. So again, this is probably where most of the work is really going to happen in looking at different projects to implement to reach sustainability. So if you're in a district that, you know, has a groundwater overdraft of 100,000 acre feet, and that's probably one of the districts I'm working in, we've either got to reduce demand or find new water. And so, you know, we're looking at a lot of different projects, flood projects, water markets and transfers. You know, that's something that's going to be really evolving over time, because I can guarantee you almost everybody has a deficiency has said they're going to go out to the market to find water. And that's going to be a really interesting change in the dynamics of the water market, that we're helping some of our districts get through. Water conservation, an obvious program that we want to try to get landowners to buy into. And then also, the basic groundwater conjunctive use facilities to try to take advantage of any available wet year water to get it into the ground to carry us through the dry years and help equalize our supply. But all of those projects, I mean, they're all things that we need to move forward. But again, kind of looking at the timing for this, a lot of them still need feasibility analysis, environmental documentation and permitting, identifying funding with whether it's within the district, raising those funds through their district process, or finding grant funds to help, and then other partnerships to within basins or across basins to develop different projects. All those things, as you guys I'm sure are well aware, take a lot of time, and that's where we look at this 20-year planning horizon as being, it's going to be fairly challenging in a good part of the Central Valley and some of the other parts of the state that really have to, have a lot of work to get to sustainability. Next slide. And then additional sustainability indicators, when we've gone through and developed a lot of the plans, there are things that we know we didn't have enough time to completely analyze. And there are some things that we know we're going to have to continue to do going forward. So that's going to be a big part of the work that has to happen, particularly over the next 5 years as we get to a 5-year update. Increased modeling for subbasins, that is something we're really going to have to look at in some places where you could only do so much in the time that we had. And in that process, identified where we needed to get better about modeling is something that we'll need to work on. Coordination between adjacent subbasins, that is another critical item. And then looking at, we came up, and most basins came up with some sustainability yield analysis. But again, as we develop more information, collect more data, I think all of these things we're going to be able to refine and get a better handle on. And that's really, again, the work that's going to happen over the next 5 years. And then sustainability indicators and groundwater dependent ecosystems, there are requirements under SGMA that we look at these specific items. But again, I think there's a lot of areas where we know we can do a better job. We needed more time to do that. And as part of the plan and a lot of basins to continue to work on looking at how we better understand subsidence, for example, or surface water, groundwater interconnections, groundwater dependent ecosystems. And obviously, for groundwater ecosystems and surface water, groundwater interactions, we've got a lot of eyes on that. So the environmental community is very interested in that. And so we're working with partners there to try to come up with some reasonable determinations about, what dependent ecosystems look like and how we can potentially protect those. And that's really, I think that's my last slide. So I do want to encourage you, if you do have questions, please raise your hand or just try to cut us off, and we're happy to kind of pause for a second. And now if you do have any questions on what I just presented, be happy to field those, or we can wait till the end, maybe before Chris and Eric start. And if there are none, we will keep moving on.
All right. Well, good evening, everybody. Glad you could join us here. My name is Eric Geiser. I'm a senior hydrogeologist with GEI, stationed out of the Pasadena office, but currently working from home in Upland. So I'm just a stone's throw away from IUA. Glad to be part of the Chino Basin area. I'll be presenting on Managed Aquifer Recharge, along with Chris Peterson. Chris, why don't you introduce yourself real quick, and then we'll delve into it.
Hi, everybody. I'm Chris Peterson, and I'm a senior hydrogeologist working out of our Rancho Cordova office near Sacramento. And I've got about 30 years of experience. Most of that is water resource related, and with a focus on conjunctive use and groundwater recharge. And I'm part of a groundwater team up here in Sacramento. We've got about 8 people on our team, and we do a wide variety of groundwater projects. So thank you so much for being with us this afternoon. You're muted, Eric.
How about now?
Yes, good.
Go ahead and go to the next slide, Lydia. So we're going to talk a little bit about just managed aquifer recharge, what it is in general, what's encompasses managed aquifer recharge. Then Chris and I are going to talk a little bit about subsurface injection, which is a new twist on an old technology, as well as some of the work that we're doing up at the Roseville ASR project. So next slide. So what is managed aquifer recharge? Well, we all kind of know what the definition of it is, but technically it's the intentional recharge or storage of surface water into an aquifer for subsequent recovery or for environmental benefits. And there's really kind of a number of ways to do this. Some of the more common ones are recharge ponds, subsurface, well, not subsurface, but infiltration networks such as injection wells and ASR wells. Something that's being practiced up in the Central Valley is the flooding of fallowed lands during flood seasons. Just let the water inundate the area and let it recharge normally. And then something I'll talk a little bit about is subsurface recharge, which is what we're going to get into here shortly. So next slide. So really, why do managed aquifer recharge? Sigma really kind of brought a highlight or spotlight to the fact that, you know, and I think a lot of districts already knew this, we simply don't have enough groundwater for us to use to meet our demands. So really, we've all been trying to figure out over the last 20, 30 years, how do we get more water into the ground when it's available so that we can use it and be more resilient during drought periods and really kind of meet our demand and level things out over the time frame. And GEI has been involved in these MAR projects going back to the early 1960s. And through that experience, you know, we've really hammered home the idea that this is a multidisciplinary endeavor. It's not just hydrogeology, it's planning, it's civil geotech engineering, there's data management aspects to it. There's a huge environmental and regulatory compliance portion to it, as well as just outreach and communication. So really all these things have to be packaged together for a successful MAR project overall from start to finish. Next slide. So subsurface recharge is kind of, as I said, it's a new twist on an old technology. What's being done is there's a few projects that are going on in the Central Valley that we're doing trials on right now to test this out. But essentially what it is, it's a French drain except in reverse. And what these projects are doing is you're taking a perforated pipe that's usually perforated just on the lower half to kind of limit any sort of infiltration of native materials into the piping for clogging purposes. And you're burying that about 15 feet below grade. You're putting a thin gravel envelope around it just to protect it and also to enhance the permeability a little bit. That's then backfilled to ground surface with native soil. And you then inject water into these piping runs that are distributed out across the property. And water then gravity drains into these systems and then recharges the subsurface. Now, the water that's delivered to these, we're obviously treating for suspended solids and TDS, trying to knock those components down as much as possible to limit any sort of physical clogging that might occur. But what some of the systems are also doing is they're including some additives to help control the biological growth. In the cases of municipalities, we have that chlorine residual that's in the water that we can use as well. So next slide. So this is a summary of one of the projects that we've been tracking. This is about a year's worth of data. The site itself is 100 acres in total. They have a system that's built very similar to what I was describing above. It's got 5 different legs to it. The graph on the right is color-coded by each leg of the system as far as deliveries went. There's a blue line just above that. That's the groundwater response in a monitoring well that was on site that was equipped with a transducer. And then the graph in the upper right is just one example of some of the infiltration rates that we calculated from it. And really over this 100-acre site with this system, in a 1-year period of operation, they were able to infiltrate 1,835 acre feet over the year, which is pretty substantial. It was a pretty impressive number. And that's through about 224 days of physical operations. And what we figured out from this system is that we saw very linear infiltration rates. We averaged about 0.4 feet per day for infiltration, which was really surprising. It was a great number. I'm very happy to see that. And that, sorry, I lost my train of thought there for a second. So really, when we took a look at this system, one of the things we wanted to do is we wanted to compare it to what a typical recharge pond would do. So if we were to take this same property, convert the entire 100 acres to a recharge pond and apply that 1/2 foot per day infiltration rate, what we see is that subsurface systems capable of recharging about 20% of that total capacity. The really nice thing though about subsurface systems is because they're below grade, there's no impact to the surface usage at all. So the farmer in this case was able to continue farming, maintain about 6 to 7 acre foot per day as a recharge rate across the site, and have no impact on their root zones or anything else. And one of the really nice things about this that can really be expanded just not only from the farming aspects, but to more urbanized areas, is these type of systems could be installed in parks, on fields, any sort of open area where you have just open access, but you don't want to lose the purpose of that land. These type of systems may be applicable to it. The other big advantage that we saw here is that from a cost standpoint, just to develop these, the subsurface system was running at about $3,000 per acre on average to design and install the actual piping and distribution systems to it. Where on the other hand, a recharge pond, you're looking at about $10,000 an acre. So with that, I'm going to turn over to Chris and he can talk more about the Roseville project.
Thanks, Eric. Yes, and so Eric's application is really more in rural areas, agricultural areas. And so ASR, aquifer storage and recovery, and injection wells is usually applied in more developed areas, municipal areas, or areas where there's a confining layer between the surface and the target aquifer that, that we're trying to recharge. And so the city of Roseville is in an area where there's about 300 feet of clay between the surface and the Merton Formation, which is the regional groundwater aquifer. So about 20 years ago, the city of Roseville began doing feasibility studies and pilot studies to look at the potential for developing an aquifer storage and recovery program. And I've been working with them for about the last 18 years. And so I've been working with them through these different phases of development, as you can see on this slide here. And the initial phase was just getting through some pilot testing, feasibility evaluations, and the big hurdle that we encountered there was regulatory permitting. In the Central Valley of California, there was no regulatory permit for injection of drinking water. And so we worked closely with the Central Valley Regional Board and came up with a strategy that ultimately culminated in a statewide ASR general order that was adopted by the state board. And so there's a much more clear permitting pathway for these types of projects now that involve injection of drinking water. So now we're in phase 3, which is expansion of the program. Roseville has 4 ASR wells, and they're in the process of expanding to 8 ASR wells. And so I'm going to talk about a couple of activities that we're doing to help with that expansion and then also some studies that we're doing to optimize their existing ASR wells. Next slide. So first of all, the work that we're doing to help them expand their program, it involves siting new well locations within the city of Roseville. And so as part of that, we've done some detailed studies looking at the hydrogeology throughout the city and evaluating areas that the city can acquire at low cost. So most of these locations that we're evaluating are in public easements, and we're doing some initial screening for potential contaminants. And then we're going in and we're doing an exploratory boring program where we're doing borehole exploratory drilling and monitoring well construction to look at both the hydrogeology and the water quality conditions at each of these locations. And so we started this program back in October, and it should end up at the end of December. And at that point, we'll have 8 sites to choose from. And then we will work with the city to select the 4 best locations for building these permanent ASR wells, which are a fairly large investment. Each one of these wells is running between $3 and $4 million with the topside facilities and the buildings that Roseville's putting over these facilities. They're very nice, and the city is actually funding this expansion with WIFIA funds through the EPA. Next slide. And then another activity we're involved in with Roseville is going back to their existing ASR wells and coming up with a program to operate these to achieve the highest possible injection performance. And with any injection well, you're moving a lot of water through the filter pack out into the formation. And so even though it's drinking water, plugging still occurs over time. And so for Roseville, we're helping them come up with a backwash scheme to remove that clogging layer that develops over time and restore the injection rates. And this involves a combination of quick surges of injection followed by extraction, and we're experimenting with different injection volumes, injection flow rates, and extraction rates, and carefully monitoring a number of things to determine which of these is having the most impact on restoring injectivity to these wells. Next slide. These are the types of things listed here on the left that we're monitoring during these backwash trials. Things like water levels, injection flow rates, pressure in various areas of the system, and as well as the solids removal in the form of sand content with a sand catcher, and then turbidity and silt density index of the water, both going in and then coming out of the formation. And because this is a fairly data intensive endeavor, and injection itself is data intensive because there's a lot of systems that you're optimizing here to maintain the highest possible injection rates. So next slide. These wells are fully automated and equipped with SCADA. And so we're working with Roseville's engineers and that are involved in the programming of their SCADA system. And so we're helping them develop both an optimal program for running these backwash cycles so that it can be done automatically, and they don't have to send operators out into the field to do these manual backwash cycles. So, but because it's very data intensive, we're also working with the engineers to develop dashboards that visually represent the data so that managers are able to quickly assess the situation and make changes as needed during the operation of these ASR wells. And I think that's my last slide. Yeah, so at this point, I guess we could entertain any questions that you might have on both what Eric and I have presented related to managed aquifer recharge.
All right, well, I'll keep, oh, go ahead, Chris.
Yeah, I was just going to say, yeah, if there's no questions, then Mike, you can take it away.
I had just a quick question for Eric on the subsurface recharge piping.
Yeah.
I was just curious, how are those typically installed? Do they do directional drilling, or like how do you install it without interfering with, say, a park?
So there's some temporary interference just in the installation, in that you're having to essentially dig a trench in order to install the piping. But then once that's done and everything's backfilled, you can resurface it very quickly and put things back into use. So from a park standpoint, you'd have a minimal downtime while you just trench and install.
I see. So you're probably not going very deep.
No, typical depth of these pipes is about 10 to 15 feet. That's really all the further you need to go.
I see. Thank you.
Sure.
Hey, Chris, Roger had a question. It says in the chat, are the adopted state ASR regs applicable to all regions, or do some regional boards adopt exceptions?
Yeah, that's a good question. Because it's adopted by the state board, it's a regulatory vehicle that's available to any of the regional boards. But it's not a mandate that the regional boards use the ASR general order as the permitting vehicle. However, I would say most regional boards are choosing to use it because in general, I think ASR is considered low threat and it provides a clear pathway to a permit. So it's a little different in every region, but at least in Northern California, most of the regional board staff that are considering ASR are using the ASR general order, the statewide general order.
Very good. Well, thanks, Chris. So Mike Cornelius here. I'll give you the 2-minute version of my background. Like Larry had commented on, we both started at Bookman Edmonston years and years ago. And then I was with Bookman Edmonston for about 5 years and with GEI now for about 16 years. And my background is in hydrogeology and in water management. And so I'm going to talk a little bit about some of the information management tools that GEI has developed to support our SIGMA efforts. And that includes both a communication portal we built and then also our data management system. So Lydia, if you can go to the next slide. So one of the things that we found from our analysis of the SIGMA regulations and everything was that there was a significant communication and engagement component. And not only was it that you had to prepare a communication and engagement plan, but you also had to demonstrate how you implemented it. So with that need and the amount of coordination that we thought it was going to take to coordinate GSP development with a wide variety of stakeholders over a broad area, we ended up developing what we call the Groundwater Communication Portal. And so this is the entry screen for one of them that we built, and this one happens to be for the Paso Robles Basin, which was a critically overdrafted basin. And the tool allows you to manage all of your stakeholder information. I believe they had over 600 stakeholders in that basin. It gives you a calendar that you can display all your, schedule all of your events. You can distribute information to all the stakeholders via e-blast, and you can include attachments for all the meetings and other documents. And then one of the, I think the most powerful features of this, Lydia, if you go to the next slide, is we added a comments module to this. So what this allows you to do is to post draft documents onto the portal and then receive comments on those documents. And you can receive comments by the individual, the agency, which GSA they're located in, and then they can submit their comments, and they can also add any attachments that they want to submit along with their comments if they so desire. But what it does, by adding your comments into the portal receives them by chapter and section. So one of the requirements of Sigma is that you don't have to respond to every comment, but you have to show how you responded to like comments. So this organizes all the comments, like I said, into chapter and section. So it's very easy to organize all the comments you got and prepare your responses. And we think it's a significant time saver rather than cutting and pasting comments out of either letters or emails or things like that. So you spend more time responding to the comments and less time preparing the comments. So now I was going to switch over to our data management system. And so one of the things I'm going to do is I'm going to stop my video here just to make sure I have enough bandwidth to show the data management system, because sometimes that gets a little sketchy here. And so I'm going to turn that off, and then I am going to share my screen. So can you see the interface for the data management system? Okay. So the demonstration that we put together for the Kern subbasin, and so GEI, we have a group of about 15 programmers that develop our information and data management tools for us. And we do a lot of work both for the Department of Water Resources developing tools, and then also for local agencies. So this is our local agency application. And this is a web-based tool. And you can see it has a lot of functions that you're probably getting used to seeing on a Google Maps type of thing. You know, we have our map that you can move around. We have a area with lots of different functionalities and tools on it. We can put a background on it, or you can either have a topo background or satellite imagery as the background, and then you can zoom in and zoom out of it. But then also what we've done, because we built this specifically for Sigma, we have these other layers over here that allow you to turn different sets of information on and off. And if you take a look here, from top to bottom, you can see we have layers for groundwater levels, groundwater storage, water quality, land subsidence, interconnected surface water, and seawater intrusion. And these are the 6 sustainability indicators for Sigma. And in addition, we have other layers for the hydrogeologic conceptual model and various boundary layers. And so now I'll step through these here real quick to give you a sense of what is some of the functionality we have here. So if we take a look at the Groundwater Levels tab and you click on that, it expands. It allows you to see what are the different sets of water level data that I have. And for example here, I'm going to turn on the groundwater level monitoring network that they developed for their subbasin. And so these are the wells that they chose for their RMS wells, or representative monitoring sites. So if we zoom in here, and if you take the cursor and hover over one of those wells, you can get a thumbnail sketch of the hydrograph for that well. So if I pick this well, then what it does is it pulls up a page that shows on the left here all of the information that was entered about that well. And on the right, it shows a little map inset of that well. And then I am not sure why it's spending so much time thinking to pull up that hydrograph, but we'll give it a second here. I'm not sure why it doesn't like that one. Well, let me back out of this one here and I will pick a different one. Yeah, maybe it'll go better this way. And I'll say this is the second time I've done this demonstration today and about the 5th time I've done it this week, and I have not had this issue. So let's see what it does here. All right. Well, it appears to be thinking on that one. So let me see if I can go to some of the other functions here and give that a second to catch up. I'm gonna back out here. And, you know, one of the things that this does is I wonder if it timed out on me. So I'll tell you what I'm going to do. I'm going to sign out and then come back in again, because that's what and that feature is actually part of our security system to so that we don't want it to. All right, I do not like that. Let me try this again here. All right. There we go. So now we have the entry page where we usually come in. And I was looking at the map viewer, but it also has a data management component as well. So when I click on the map viewer, it'll pull up the application. And like I was saying, it does have various levels of security built into it to protect the data, because believe it or not, these things do get attacked by outside sources. And I'm not going to go through the tour here because I gave you a brief look at that. But I'm going to go back over here and select the wells. And if I pick a well here, let's see if it wants to pull up that water level data. So here it worked this time here. So again, it has the information about the well here on the left. It has the map with the well on there. And then it also provides the hydrograph for that well. And you can see it includes different colored bands here, the blue, green, peach, and kind of a pinkish color that represent the different water year types. And then it also has the hydrograph for that well. And then for this well, since it is one of the RMS wells, it also has the minimum threshold and the measurable objective for that well. And then one of the things you can do here is you can move the scale around. So if you only want to look at a certain part of the hydrograph, you can do that. But one of the nice things about this tool is that we can go back up here and pick a second well, and it will also display on that same hydrograph. And so you can see these two wells that I picked have a very similar trend to them. And if I pick another well here, I'll go up here and pick one. That one only has 1 point, so that must have been added very recently. Or maybe that's a dedicated monitoring well that was just installed. So here, we'll pick this one over here. So there you can see, so I just happened to pick 3 wells that have a very similar hydrograph for them. And so these are the wells that they're using as their RMS wells in this part of the basin. So one of the nice things about this, to do some of the reporting functions on this, if you click this button here, then you can actually print that hydrograph. And so it makes it very easy to put it into a report. And then we can also download the data very easily. And so the idea behind the data management system is that we want to make it as intuitive for the user to use, and then 2, make it as functional as possible. So we use Excel templates both to upload and import data into the DMS, and then also you can export it and download that. So if I click on this file here, this is the well information template. So you can see it provides the information from the database for those 3 wells. Or if we take a look at the sustainable management criteria, you can see that for those 3 wells I selected, you can see here are the minimum thresholds for those 3 wells for 2020, the measurable objective for those 3 wells for 2020, and then the MOs for 2040 and the MTs for 2040. So you can populate this and you can change what you want your measurable objective to be and your minimum thresholds to be over time if you don't quite dial those in and get those right the first time. So I'm going to back out of this here. And then one of the other things we can do, like I was saying, we can add lots of other supplemental data. So for example, if we want to overlay the Corcoran clay on here, we can include the extent of the Corcoran clay, so you can see that showed up here as well. And then we can also add other features. Say, for example, I want to add the groundwater model grid. So they use a C2 VSIM, which is the Central Valley model that covers the entire Central Valley. We just put in the model grid for the Kern County area because otherwise it takes a little too long to load for demonstration purposes. But then if we can lighten that up a little bit and then come over here and we can zoom in, then we can see where our wells are relative to the model grid and whether they overlie the Corcoran clay or not. So it gives us the opportunity to take a look at lots of sets of information to evaluate and think about management actions that are going to affect these wells. And similarly to the well hydrograph I was showing, we can have a print function here as well. So we can print the map. And so, for example, I'll just move the legend out of the way. So these are the different GSAs located within the Kern subbasin. And you know, I didn't quite get that right, so I'm gonna zoom out a little bit here. And then you can produce the maps or produce figures right out of the data management system. So you can use this to produce figures for reports and things like that. So we think that's a very useful tool. And then I think I've got about 5 minutes left, so I want to show one more thing here, and I can go longer if people are interested, but I want to make sure I respect everyone's time on that. So I'm going to turn off turn that off, and I'm going to turn off the groundwater level monitoring program, and I'm going to select the water quality wells. So now if we pick a well here, for example, find a good one that has, I'll take this one here. That one had some TDS data. So similarly, we can show the trend lines for that well, and same thing with the information on the well on the left, the map on the right, and then we have the trend line for this well based on the observations over time, as well as the minimum threshold and the measurable objective. So in this case, we want to make sure that we're maintaining TDS levels in this level here. And so we stay below the measurable objective as possible, but definitely below the minimum threshold. So this is just one of the constituents. So we can take a look here and look at other constituents that has data available. So for example, if we take a look at arsenic, you can see this well has some higher levels of arsenic, and then it's been decreasing over time. And so it gives you that sense of what is that well trending like and over time. And then we can also add, like we can with the wells, with the groundwater levels, a second hydrograph. So we can display multiple wells, and so we can do that comparison of the water quality at different wells, whether they're nearby wells or further apart. So with that, I will ask to see if it's about 3 minutes before 6. First, if there's any questions, or two, if anyone wants to hang around a little bit longer to see a little bit more of the functionality of the data management system.
This is Pietro. I have a question. I'm assuming GEI is going to set up this type of data management system for your customer. Is the system, then the customer is able to kind of upload the data or play around or maintain this type of system, or do you still need your support over time?
No, we constructed it with the idea that we can build the infrastructure with the idea of turning it over to the client so they can fully operate it without additional consultant support if they choose to do that. We're here to help, but we really want to empower the agency with the ability to do that. And so when we go to the data management tab here, you can see there's different ways to import your data and to export your data and generate reports. And so, for example, if we take a look and we say to import data, then what it will do is it will ask you, okay, what data do you want to add? Do you want to add well data or station data or agency data? And so if you wanted to add a well data, then it says, okay, well, what type of well data? And so these are the different templates that you use to populate the database. And so you as the agency, different people might have different levels of authorization to do different things with the data. And so again, like I was saying, it's really the idea is to empower the user to be able to do it without consulting support.
That's great. Also, I think I saw one of the on your screen. It was I think it was also like a modeling. I believe is something that at that point I think we need someone, an expert on that. So it's modeling something that it's something that GEI offer, or something that we can upload into the system. I think there was an option modeling, or
yeah. So we can do the modeling.
Oh, the model, yeah.
Yeah, but for example, what we did, GEI did not do the modeling for the Kern subbasin. There was another contractor who did that. But for example, because that's an IWFM platform that's promoted by the department, we have quite a bit of experience doing that type of modeling. But the modeling platform, the database is separate or different. It's not, you're not constricted to one type of modeling. So what we did is we just imported the model grid. And then you can also import, the data sets associated with that and use this as a visualization tool for that model data.
So you may, there's, like you said, different consultant work on the modeling, or if you even work for the modeling, we can upload in here, use this more as a visualization data. But at the same time, can we, show if you click, let's say, on a well trend over time or something like that?
Yeah.
Or, okay.
Right.
That's great.
Yeah,
so it's very flexible. Can I really allow the client to really use this as a tool to make decision? And maybe what about to educate the regional board or entities that they may need to maybe use that for as a for compliance purposes.
Yeah, absolutely. And it's nice, like I had showed the, the model grid, and I just put the grid back up there, and if you wanted to show, going back to the groundwater monitoring wells, and I'll lighten that grid a little bit again, and if we add the, say, for example, we wanted to add, let's see here, some other information, if it's the, the geologic map of the state, you can add and subtract different coverages and layers, and then you can, zoom in here and do that comparison of, okay, well, this well is in this, geologic area, it's overlain by, or it sits over the Corcoran clay or not, and then you can print that to produce the maps that you want to see. And so I think it's a very useful tool for that visualization and display of information associated with your groundwater basin.
Very interesting. Yeah, very nice. I feel you can spend all day just showing all the different features. So.
Oh, absolutely. Well, before the meeting, I was actually late to our group getting together because I was playing with this again because I'm constantly kind of exploring and checking and seeing what things haven't I found yet.
Okay.
So yeah, it is very useful.
Yeah, I just want to respect your time. Just a quick question for Eric. You mentioned about the Subsurface Recharger, and I think one of your slides was showing the volume that was recharged, I think, over time.
Yes.
So I'm assuming that's an estimate based on maybe rain events, or how do you measure that based on the project design?
Yeah, so that was actually, we had flow meters on
wow.
each of the various legs of the system. So we knew exactly how much water was being sent to the system for delivery, and then just watch that recharge into the subsurface. So yeah, that's very accurate as far as the actual volume that was recharged artificially.
Okay, great. Because my follow-up question was like, if it was an estimate, how, the next step, I'm sure whoever was responsible for the recharge want to make sure he's is the one that allocated the water rights for that. But since you're doing the flow measurement, I'm sure there's no really issue if there's a multiple stakeholder in terms of the allocation of the water rights. So,
Correct.
Okay, perfect. Thank you.
You're
Hey,
welcome.
Mike,
Yes.
Roger had a question related to Pietro's question. Does the DMS require any special application to be hosted locally on your PC, or is it a web-based application and accessible from any PC with a login?
It is. That's correct. It is. It doesn't require any software on the computer. It is fully web-based. So all you need is the login to get in and use it.
And then he was wondering if there are plans for a smart app for a tablet or smartphone.
Yeah, we actually have those developed already. Because we've built those not necessarily for this application yet, but we have done that for other clients to go out and collect both groundwater data as well as like data during flood events as well. So yeah, we built multiple types of data collection tools to take out in the field.
Great.
And Pietro, just real quick, if you do want to talk about this all day, I'm sure Mike would be happy to schedule an appointment with you to come down.
Absolutely, yeah. No, absolutely. I'd be more than happy to do that.
I appreciate your availability.
Yeah, very good. So, well, excellent.
Well, if there's no more questions, and we can obviously stick around if you guys have other questions or like Mike said, want to see something else, we're more than happy to do that. But I would like to say thank you for joining us. Hopefully we've shared some useful information about the kind of work that we do. And then if you want to reach out to any of us, I think, you'll get an email from us and it'll have our contact information if you didn't have that from the invitation. But we'll make sure you have that. So feel free to reach out to any of us. And again, appreciate your time and hope you enjoyed the Grubhub gift certificate and had a little bite to eat while you're watching our presentations today.